Hello everyone, this is Vinay Kumar Case. My lesson is 1V 196035 under the guidance of Dr. Lata MS, Department of Civil Engineering, SVC, Bengaluru. My seminar topic is Zero Energy Building. Introduction. The building industry and scientific communities across the world have identified the importance and need for energy efficiency in the buildings. They initiated significant efforts in this direction. Buildings Buildings have a significant impact on energy use and the environment. Commercial and residential buildings use almost 40% of primary energy and approximately 70% of electricity. Zero energy building is not a single product or technology, but rather a combination of closely integrated involving techniques. This is the diagram of energy consumption diagram. What is zero energy buildings? A zero energy building is a building with a net zero energy consumption. The total amount of renewable energy used by building on an annual basis is roughly equal to the amount of energy generated and the site of the renewable sources. These buildings consequently contributed less overall greenhouse gases to the atmosphere than similar non-zero energy buildings. Why? To overcome energy crisis, reduce energy consumption, reduces greenhouse gases or carbon emissions and global warming, reduces dependence and fossil fuels, protects our environment for future generation. How zero energy can be achieved? PCM walls, ventilation system, green roofs, renewable energy resources. PCM walls. A phase change material is a substance works on the principle of heat of fusion in which melting and solidifying at a certain temperature is capable of storing and releasing large amounts of energy. Heat is absorbed or released when the material changes from the solid to liquid and vice versa. When the PCM is in its solid phase, it will absorb heat as the external temperature rises. The temperature of PCM will mirror the external temperature until the PCM's melting point is reached. This is a working cycle of PCM. Working. When the external temperature reaches the melt point of the PCM will begin to melt, that is changes phase. During the phase change process, the PCM will absorb large amount of heat with almost no change in temperature. During this time period, the PCM is providing a cooling effect. The reverse cycle occurs as the external temperature cools. The PCM, now its liquid phase, can release the heat is absorbed as the external temperature decreases. During this period, the PCM solidified and produces a warming effect. Heat recovery and energy recovery ventilators. To reduce energy loss in zero energy homes, heat from the ventilated air can be captured rather than the wasted by installing heat recovery ventilators or energy recovery ventilators. These ventilators bring fresh air into home and discharge stale air while retaining about 70% to 90% of heat from the discharge air and returning into the incoming air. Both types of recovery devices use an exchange core to pass heat from an airstream to the others. This is a working of ERV. Working. The exchange core in an HRV can be aluminum or plastic. This core prevents indoor moisture and water from crossing into the flow of fresh outside air. HRV are the best for cool climates, however, ERVs are better choice in the warm and humid or extremely dry climates. ERVs are the same HRVs except the core is made of coated paper or perforated plastic, which allows water vapors to pass. Green roof. A building roof that is either or partly covered with a layer of vegetation is called a green roof. It is layered composition system consisting of a waterproofing membrane, growing medium and vegetation layer itself. A green roof system incurs higher annual savings when installed an poorly insulated roof rather than a well insulated roof. The moisture content in growing media of green roof influence its insulating properties. This is the green roof diagram. Green roof, it's continued. The wetter the medium, the poorer the insulating behavior compared to the dry growing medium. Therefore, green roofs reflect solar radiation more efficiently than conventional roofs. Photovoltaic solar cells. Each photovoltaic cell is basically an sandwich made up of two slices of semiconducting materials, usually silicon. To work, photovoltaic cells needs to establish an electric field, much like a magnetic field, which occurs due to opposite poles. An electric field occurs when opposite charges are separated. To get this field, manufacturers dope silicon with other materials, giving each slice of sandwich a positive or negative electric charge. This is a solar panel of picture, and this working is they seed phosphorus into the top layer of silicon, which adds extra electrons with a negative charge to that layer. Meanwhile, the bottom layer get a dose of boron, which results in fewer electrons or positive charges. This will adds up to an electric field to the junction between silicon layers. Then, when a photon of sunlight knocks an electron free, the electric field will push that electron out of the silicon junction. A couple of other components of the cells turns these electrons into the useful power. Metal conductive plates and the slides of the cells collects electrons and they transfer them to the wires. Architectural design of building. Preservation preservation of maximum possible number of trees standing over the site. Solar passive architectural with proper orientation and shading of fenestration. Appropriate building envelope design with the envelope insulation to reduce to heat intake. The building is designed in such a way that there is a free ventilation across the entire building. Energy conservation measures. Utilization of high efficiency solar panels to achieve net zero criteria. Energy efficient T5 and LED fixtures. Water cooled chillers. Geothermal heat exchange technology used for heat rejection from air conditioning system. Innovative chilled beam system for cooling. And these advantages of zero energy building. Isolation for building owners from future energy prices increases. Increased comfort due to more uniform interior temperatures. Reduced requirement for energy. Reduced total net monthly cost of living. Minimized extra cost. And the reduced total cost of ownership due to improved energy efficiency. Disadvantages. Initial cost of higher, lack of skills or experience to build zero energy buildings. Solar energy captured using the house envelope, only workers in location unobstructed from the sun. Challenges to recover higher initial cost and resale of buildings, climate changes or global warming. The Indira Paryavaran Bhavan, New Delhi. This is the first zero energy building started in India, constructed with adoption of solar, passive design and energy efficient building materials. Instead, installed capacity of 930 kilowatt peak power. The building has the largest roof-type solar system among multi-stored buildings in India. More than 50% area outside the building is soft area with plantation and grass. This is the Indira Paryavaran Bhavan, New Delhi picture, and this conclusion is, with the advancement in renewable technology, zero energy buildings are the future. Many governments are providing subsidies to individual and organization for creating zero energy buildings. Solar energy, wind energy will be the major contributor of renewable energy for zero energy buildings, owing to their widespread availability. Geothermal energy is an upcoming from energy having great potential to generate electricity, but a lot of research still has done to tap into its full of potential. Thank you.